So in this video, let us look at extreme value questions or questions based on boundedness of trigonometric functions. So the first question that we're going to see is you need to solve the equation cos x into cos 6x is equal to minus 1. So how do we solve this? To solve this directly will be a very hectic task, because cos 6x, if you try to expand it, it will be a sixth power of cos x. You'll get an equation in cos x whose degree is 6. So cos x into 6th degree, you get a 7th degree equation. You cannot solve it. So what I observe here is cos x into cos 6x is equal to minus 1. Cos x is a number which lies in between minus 1 and plus 1. That means cos x will always be a fraction unless it is minus 1 and plus 1. Similarly, cos 6x also lies between minus 1 and plus 1. So the product of these two numbers have to be equal to minus 1. So if this is a fraction and this is a fraction, the product of two fractions can never be equal to a complete integer. So if this has to be an integer, there is only one option where cos x and cos 6x should be such that the product is equal to minus 1. So for this to happen, cos x to be equal to 1 and cos 6x has to be equal to minus 1, or vice versa. It is cos x is equal to minus 1 and cos 6x is equal to 1. So for this to happen, one of this has to happen. So let us see the first case. Cos x is equal to 1 implies x is equal to 2m pi, right? Something which you have derived already. And cos 6x is equal to minus 1. This implies 6x is equal to 2m plus 1 times pi. So x has to be equal to an even multiple of pi and 6x has to be equal to an odd multiple of pi. This implies x has to be equal to 2m plus 1 times pi by 6. So for this condition to be valid, cos x is equal to 1 and cos 6x is equal to minus 1, x has to be an even multiple of pi and also an odd multiple of pi by 6. So can an even multiple of pi be equal to an odd multiple of pi by 6? No, because 2n pi can be written as 12n times pi by 6, right? It's nothing but 12n times pi by 6. This is an odd multiple of pi by 6. This is an even multiple of pi by 6. Both cannot happen simultaneously. It means there is no solution according to case 1. So this case does not have a solution. Let us go to case 2, where cos x is equal to minus 1 and cos 6x is equal to 1. So x has to be equal to an odd multiple of pi and 6x has to be an even multiple of pi. 6x has to be equal to 2m pi. So this implies x has to be equal to 2m times pi by 6. There is an even multiple of pi by 6. So if you go to this, x is equal to 2n plus 1 times pi by 6 into 6, right? So the first condition says that x has to be of the form 6 times 2n plus 1 times pi by 6. And for this to be valid, x has to be of the form 2m times pi by 6. Even multiple of pi by 6, and this is also an even multiple of pi by 6. So this is all even multiples of pi by 6. This contains only certain even multiples of pi by 6. So x has to be satisfying both the conditions. So obviously this is a subset of this. This is a subset of this. So intersection will be equal to this, right? Because all the numbers present in this are even multiples of pi by 6. But this does not cover all even multiples. If you put n is equal to 1, you get 6 pi by 6. Which comes if you put m is equal to 3. If you put n is equal to 1, you get 6 into 3, 18 pi by 6. You get 18 pi by 6 here also. So all the solutions available in this are also solutions for this. So effectively, the common solution for these two is x is equal to 2n plus 1 times pi. Means if x is an odd multiple of pi, this equation is valid. Cos x will be equal to -1 and cos 6x will be equal to +1. Hence, the product of these two will be equal to -1. So the answer to this equation is x is equal to 2n plus 1 times pi, and the principal solutions are only 1 pi. All the other solutions are not principal solutions. So in this question, you're asked to find the number of ordered pairs x comma y in open 0 to 2 pi such that sin x into cos y is equal to 1. So the equation that needs to be satisfied is sin x times cos y is equal to 1. This is also a question based on the boundedness property of sin and cos. We know that sin always lies between -1 and +1 and cos always lies between -1 and +1. The product of these two will be equal to 1 only in two cases. That is, if this has to be equal to 1, then sin x is equal to 1 and cos y has to be equal to 1, or both of them can be equal to 1, or sin x is equal to -1 and cos y is equal to -1. So only in these two cases can this be valid. So this implies, let us see these cases, sin x is equal to 1 implies x is equal to, where will sin x be equal to 1? We have already solved this, 4n plus 1 times pi by 2, and cos y is equal to 1 implies y is equal to 2m pi, even multiples of pi. Cos y will be equal to 1. So this is one option. Or sin x has to be equal to -1 implies x is equal to 4n minus 1 times pi by 2. We have already derived this. And y should be equal to 2m plus 1 times pi, odd multiples of pi. So now let us look for solutions in open 0 to 2 pi. So for this case, x is equal to 4n plus 1 times pi by 2. So if you put n is equal to 0, you get pi by 2. X can take values of pi by 2. And the next value is n is equal to 1. That is 5 times pi by 2. This is beyond 2 pi. So you have only one solution between 0 to 2 pi. And y is equal to 2m pi, even multiples of pi. So you get the first solution as 0, next solution is 2 pi, next solution is 4 pi, so on. But none of these are valid because I want solutions only in open 0 to 2 pi. So I don't want 0 or 2 pi. So effectively, this part of the solution does not give you any solution. If you go to the second one, x is equal to n minus 1 times pi by 2, 4n minus 1 times pi by 2. So x can take the value of, if you put n is equal to 1, you get 3 pi by 2. This is okay. And the values of y are odd multiples of pi. If you put m is equal to 0, you get pi. All the other values are beyond 0 to 2 pi. So this x and this y both lie in 0 to 2 pi. Hence, this is a solution to this equation. Hence, the number of ordered pairs satisfying this equation is only 1. So the answer is only 1. So in this question, given that 3 sin x plus 4 cos ax has to be equal to 7, this equation has to have at least one solution. If that is so, how many possible values of a are there? So again, this is also a question based on the boundedness of trigonometric functions, because sin x can take a maximum value of 1 and cos ax can also take a maximum of 1. So only if both take the maximum values can this expression be equal to 7. So 3 plus 4 is equal to 7. So even if one of them go below 1, you cannot get 7 as the sum of these two. So if this equation has to be valid, so sin x has to be equal to 1 and cos ax should also be equal to 1. This implies x has to be equal to 4n plus 1 times pi by 2, right? And ax has to be equal to, cos x is equal to 1, that means even multiples of pi, 2m So x has to be equal to 4n plus 1 times pi by 2. Ax has to be equal to 2m pi. So this implies x is equal to 2m pi by a. So for this equation to have at least one solution, you should have some solution which looks like this as well as this. My x has to look like 4n plus 1 times pi by 2. My x also have to look like 2m pi by a. So for these two types of solutions to have a common solution, you need 4n plus 1 times pi by 2 to be equal to 2m pi by a. So this pi and this pi gets cancelled. This implies a has to be of the form 4m by 4n plus 1. So a has to be of the form 4m by 4n plus 1. So if a is of this form, you will have at least one solution to this equation. For example, a can be of the form m is equal to 1. I'll put n is equal to 1. That is 4 by 4 plus 1 is 4 by 5. So on, you can have different values of a which satisfy this condition. So in this question, you're given the equation cos power 50x minus sin power 50x is equal to 1. You're asked to solve this. Obviously, power 50 equation, degree 50 equation cannot be solved directly. So this question is a question based on boundedness property. So what I do is cos power 50x is equal to 1 plus sin power 50x, right? Cos power 50x is equal to 1 plus sin power 50x. So just observe this part of the equation. 1 plus sin power 50 is always greater than or equal to 0. It cannot be negative. So 1 plus is some number which is greater than or equal to 0. That is RHS is always greater than or equal to 1. But the LHS is cos x power 50. This will always be less than or equal to 1. So if these two have to be equal, there is only one condition. There is only one way in which both can be equal, that is cos power 50x is equal to 1, and this is also equal to 1 plus sin power 50x. If both sides are equal to 1, then there is a chance that these two are equal. That means cos x is equal to plus or minus 1 and sin x should be equal to 0, right? Because 1 is equal to 1, sin x has to be equal to 0. So for this equation to be valid, cos x has to be plus or minus 1 and sin x has to be equal to 0. Cos x is equal to plus or minus 1 implies x is cos square x is equal to 1 effectively. So x is equal to n pi. This 1 corresponds to cos square 0, so you won't have anything. X is equal to n pi. And sin x has to be equal to 0. That means x is also equal to n pi. For both the equations, the solution is n pi. Hence, the answer, the solution for this question is x is equal to multiples of pi, where n belongs to integers. That's the answer to this question. So this question, you're given the equation 12 sin x plus 5 cos x is equal to 2y square minus 8y plus 21. You have a trigonometric expression here, you have a quadratic expression here. This is in terms of x, this is in terms of y. So you're asked to solve this. You're asked to solve for both x and y. So how do we do this? Again, this is also a question based on boundedness. So obviously you cannot directly try to solve this because trigonometric expression, quadratic expression, they cannot be solved simultaneously. And one side is in the terms of x, the other side is in terms of y. So you cannot directly try to solve it. So what I try is, first I'll try to see the minimum value of this quadratic expression. So if you take 2y square minus 8y plus 21 is a quadratic expression. So the minimum value of this can be found out using the formula minus of d by 4 times a. That is equal to minus of, what is the discriminant of this? B square minus 4ac. B square is 64 minus 4 into a into c, that is 8 times 21. B square minus 4ac by 4 times a is 8. That is nothing but minus of, if you cancel 8 out, you get 8 minus 21. That is equal to 21 minus 8, which is equal to 13. 21 minus 8 is equal to 13, right? That means this value will always be greater than or equal to 13. So this is a formula which we get in the chapter of quadratic equations and expressions. Otherwise, if you want to do it directly, you can also use the method of completion of squares to get this value. So what you can do is you can write this expression as 2 times y square minus 4y plus 21. You just need to complete the square here. 2 times y square minus 4y plus 4 minus 4 plus 21. So y square minus 4y plus 4 becomes y minus 2 whole square. It is 2 times y minus 2 whole square minus 8 plus 21 is plus 13. So this expression can be written as 2 times y minus 2 whole square plus 13. Now we know that y minus 2 whole square is always greater than or equal to 0, into 2 is always greater than or equal to 0, plus 13 is always greater than or equal to 13. So we get the same answer from this formula and this method. Actually, this is derived by this method. So you can remember this formula, minus d by 4a gives you the minimum value of a quadratic expression whose leading coefficient is positive. Now this side we have found that is always greater than or equal to 13. Now let us analyze the LHS. 12 sin x plus 5 cos x. This is of the form a sin x plus b cos x. So we usually divide this with root of a square plus b square. That is 13 and 13. Root of 12 square plus 5 square is 13. So now if you draw a triangle whose sides are 12 and 5, so the hypotenuse becomes 13. So 12 out of 13 is nothing but sin theta. 5 out of 13 is cos theta. Is of the form sin a sin b plus cos a cos b. So cos of x minus theta times 13. 13 times cos x minus theta. So this can be written as 13 times cos of some x minus theta is equal to 2y square minus 8y plus 21. So cos is always less than or equal to 1. So this side is always less than or equal to 13. And this side is always greater than or equal to 13. For these two to be equal, both have to be equal to 13. So for this equation to be satisfied, cos x minus theta has to be equal to 1. That is 13 times cos x minus theta has to be equal to 13. So cos x minus theta has to be equal to 1, and this expression has to be exactly equal to 13. That means y has to be equal to 2. So if this is 0, then this value is 13. So y has to be equal to 2. Right? So if you want to do by the formula, this is the minimum value, and this minimum value occurs at minus b by 2a. That's the formula. This minus of minus 8 by 2a is 4. Is equal to 2. You're getting the same answer. So y has to be equal to 2 for this equation to be valid, and cos x minus theta has to be equal to 1. So x minus theta has to be equal to 2m pi, right? Even multiples of pi. So x is equal to 2m pi plus theta. So this is the possible value of x, and this is the possible value of y. So where theta is some angle whose tan is equal to 12 by 5. Is tan is 2.4. So correspond to tan theta is equal to 2.4. You get some angle theta. So that is the angle which you need to use here. So I hope you have understood this question. Thank you.